Okay, so today we're going to, in lesson 2, expand our understanding of rational exponents by applying the properties of rational exponents. So some of this is a review from Algebra 1, but some of it is going to be a little new because we're dealing with fractions, so it's a little bit more in depth. So what we're going to talk about is these properties. I'm going to run through them and then I'm going to show you them in action, kind of with actual numbers. So the first one, product of powers. This says if I multiply two powers with the same base, I add the exponents. Okay, I add the exponents. And I've got a little example with numbers on the right to help you with that. Okay, next one, a power of a power. If I raise a power to a power, I multiply the exponents, right? I multiply the exponents. The next one, power of a product. If I am raising the product of two numbers to a power, it is a little bit like you distribute. You distribute that power through each factor. You apply this on A, you apply this power on B, okay? Negative exponent, we talked about last lesson. It creates a reciprocal. Okay. Zero exponent, something raised to the zero power, is 1, except for when we raise 0 to the 0 power. That's undefined. Next one, quotient of powers. When we multiply two powers at the same base, we add the exponents. When we divide two powers with the same base, we subtract the exponents. All right? And then finally, power of a quotient is the same as power of a product. Okay? Same idea. When you have a power being, or a fraction being raised to a power, you distribute that power to each part, denominator and numerator. Okay? So, example 1 basically just runs through the properties of exponents. So in part A, this is a product of powers, okay? Two powers with the same base, I add the exponents. So this is 7 to the 1/4 plus 1/2, which is really 7 to the 3/4 power. And then I'm done. Part B, this is the power of a product and power of a power. This combines two properties. So I raise 6 to the 1/2, I raise that to the second power. 4 to the 1/3, I raise that to the second power. So this really becomes 6 times 4 to the 2/3 power, and I would actually leave it like that. The reason this is 6 is because 1/2 times 2 is 1, 6 to the 1 is 6. The reason the other factor is 2/3 is because 1/3 times 2 is 2/3. Part C is another power of a product, but it involves a negative exponent. So what I'm going to do first, before I do anything else, is write the reciprocal. 1 over 4 to the 5th times 3 to the 5th, that to the 1/5. So that's that property of a negative exponent. And then this is 1 over 4 to the 1st and 3 to the 1st, because 5 times 1/5 is 1 for both of these powers. So this becomes 1 over 12. 4 times 3 is 12. So that one's finished. That is our final simplified expression or number. Part D. This one is a quotient of powers. So we are dividing two powers with the same base. We subtract the exponents. So this would be 1 minus 1/3. So 5 to the 2/3 power. So I subtract the exponents when I divide two powers with the same base. And as far as part E goes, we're raising a quotient, or a power of a quotient. Power of a quotient. So this would be on the top. It would be 42 to the 2/3 power, and then 6 to the 2/3 power. Okay, So the thing here I want us to recognize, I did the power to a power, 1/3 times 2, 1/3 times 2. What I want us to notice is both of these powers have the same exponent. So what I could do is I could kind of reverse the power of a quotient and rewrite this as 42 over 6 all to the 2/3 power, which is really 7 to the 2/3 power. So I didn't really show you that in the beginning, but if we have a fraction where each of the powers are raised to the same exponent, we can write that fraction to that single exponent. So I'm okay with us leaving this as a fractional power here, 7 to the 2/3, because that's going to be a decimal. I'm just focused on us understanding the properties of these powers. So moving along, we talked about rational exponents. Now we're going to talk about radicals. So some properties of radicals. One property of radicals says, if I am multiplying two radicals that have the same root, I can multiply what's inside each of those roots by each other. So an example is the cube root of 4 times the cube root of 3 is really the cube root of 4 times 2, which is 8. That's how we get 8. The cube root of 8 is 2. But it's understanding I can write these as a single multiplication, all right, single product. Quotient property follows the same steps. If I have the 4th root of 162 divided by the 4th root of 2, I can write this as the 4th root of 162 divided by 2, which simplifies to be the 4th root of 81, which simplifies to be 3. And I'm going to just put a little edit there, plus or minus 3. Okay, plus or minus 3. So that part of it, if you forget the plus or minus, I'm just going to emphasize that we remember even root, we get that plus or minus. Okay. So in example 2, what we look at is we can take the 3rd root of 12 times 18. Okay, 12 times 18, which I believe is 216. I'm just going to double check on my calculator. 216. So this can be the 3rd root of, or the cube root of, 216. 216. The cube root of 216 is 6. 6 times 6 times 6 is 216. So it's just writing these as a single product under the same root. For part B, I can write these as a single root, 80 divided by 5. So this would be the 4th root of 16, which is plus or minus 2. Okay, didn't put my box around 6 there, but plus or minus 2 because it's an even root. So simplifying that. So those is just understanding we can write those as a single root, as long as the roots are the same. Adding and subtracting, like radicals and roots, is a little different, but I think of it as no different than combining like terms. Okay, terms. So in part A, this is not the 4th root of 20. I don't do 10 plus 10. These are the same root, same number inside the root. So this is 1 root, 1/4 root of 10 plus 1/4 root of 10 is 2 4th roots of 10. For part B, I look at this as 2 5th roots of 8 plus 10 5th roots of 8 is really 12 5th roots of 8. So you notice how the power does not thing, that's not very academic language. The power is identical in both terms. So I just combine the 2 and the 10 there. In part C, this one's a little tough because the roots are not the same, so I can't just do 54 minus 2. I've got to look at 54, and I've got to simplify that. I'm going to pull that apart by factoring it, and it's understanding that for these to be like roots, I want to have the 3rd root of 2. So I'm going to do 54 divided by 2 is 27. That's understanding the cube root of 27 is 3. So this would be 3 cube roots of 2. So my problem becomes 3 cube roots of 2 minus 1 cube root of 2, which is 2 cube roots of 2. So essentially, if the roots are being added or subtracted and they are not identical, divide the bigger one by the smaller one to break it down, and you can combine those roots in the end. Now, for the guided practice, what I'm going to tell you is I'm going to have you for right now, you're not going to deal with 8, okay? You're not going to deal with 8. And I'd like you to just hold off on doing number 7, okay? I'm going to do a quick fix on number 5 as well, okay? So if you can wait on number 7. For number 5, I just messed up my operation. This is 4th root of 27 times the 4th root of 3. So that's multiplication, okay? So take a minute, try these, come back when you're ready, resume the video, and I'll go through my answers. Okay, so for these examples, for number 5, I could just multiply 27 by 3 to get 81. 4th root of 81 is plus or minus 3, right? Plus or minus 3. For number 6, 250 divided by 2 is 125. The cube root of 125 is 5. So that's how I got 5. For 9 and 10, just like combining like terms, 7 minus 1 is 6. 6 fifth roots of 12 for number 9. Number 10, 4 plus 8, I got 12 times 9 to the 2/3. So just combining the like terms. 11, I had to do a little bit extra work for 11. I had to turn this into a cube root of 5. So I did 40 divided by 5 is 8. The cube root of 8 is 2. So this turned into 2 cube roots of 5 plus 1 cube root of 5, which became 3 cube roots of 5. So number 7 is a little tougher because I am breaking this down, but unlike the other ones, like in number 11, I knew to divide 40 by 5. This one I don't know what to divide by. So what I'm going to divide this by is a perfect cube, okay? And I'm going to give you guys kind of a hint on what the perfect cubes are, or what the perfect cubes are up to like the first few numbers. 8 is a perfect cube. 2 times 2 times 2, okay? 27 is a perfect cube. 3 times 3 times 3. 64 is a perfect cube. 4 times 4 times 4. 125 is a perfect cube. 5 times 5 times 5. So literally what you can do is you can divide each of these, or divide 104 by each of these, see which one actually is a factor of 104, and then break it down that way. 125 is out of the question because it's bigger. If you test 64, that is not a factor. 27 is not a factor. 8 is the only perfect cube that is a factor of 104. So when I break that down, 3 times 13 is 104. So it's understanding the cube root of 8 is 2. It's a terrible 2. 2. So my final simplified radical is 2 times the cube root of 13. And that is simplified all the way. Now, that is more or less just to get you some practice on what I mean when I say perfect cubes, okay? Or breaking something down or factoring something out. So right now, you're probably ready for the practice. Make sure that you're taking your time, checking your answers, and making sense of what the lesson is or what I expect before you move on to those checkpoints, okay?